Hello everyone. We begin with the second part of statistics. We have already understood how to calculate the mean and the mode. In today's lesson, we will deal with calculation of median. Let's take an example. Suppose we have to find the median of the following data, which gives the marks out of 50 obtained by 100 students in a test. The first step is to arrange the marks in an ascending order and prepare a frequency table as you can see. Once we get the marks in an ascending order, the second step is to make the cumulative frequency. To take the cumulative frequency, we find out whatever is the frequency in the second row and we go on adding. For example, marks obtained by 20 students is 6 and the second row, which was 25, now we change it to up to 20, up to 28. So what happens? So marks scored up to 25 cannot be 20, so we'll have to add 6 also to it. Hence it becomes 26. Similarly, marks obtained up to 28 would be 50. Marks obtained up to 29, 50 plus 28 is 78, and it goes on. And one very important thing to remember, when the total number of observations are an even number, as in this example, which is 100, to take out the median, we have to take n by 2 and n by 2 plus 1. And the observation of these two would give you the median once you take out the average of these. Let us see how to go about. When we divide 100 by 2, because 100 is n, we get 50. And when we divide 100 by 2 plus 1 we add to it, so we get 51. Which means it is the 50th and the 51st observation, and the average of these two will give us the median. Now the 50th observation will fall under the cumulative frequency column 50 over here. So when we look straight to the marks obtained column, we find it is 28. So 50th observation is 28 and 51st observation will fall under 78. So if you look straight from 78 to the marks obtained column, the observation of the 51st observation is 29. The median is 28 plus 29 divided by 2, which is 28.5. Now let us understand how to calculate the median of grouped data. The median of grouped data can be calculated through the formula L plus n by 2 minus Cf by F into H. Now understanding what are these symbols and terms denoting. L represents the lower limit of the median class. N, as I've just explained, is number of observations divided by 2. Cf is the cumulative frequency and H is the class size. Let's understand this with an example. The following table gives the distribution of lifetime of 400 neon lamps. So this is the class interval, which is the lifetime in hours, and number of lamps is the frequency column. The first step is to convert the frequency to cumulative frequency. So once we calculate the cumulative frequency by adding to the subsequent rows, we get this in order. Now 400 is n. It is an even number. So 400, when we divide by 2, we get 200. So 200 will lie in the row 216. So 216 will lead to the class interval column, which is 3000 to 3500. So we call 3000 to 3500 the median class, where 3000 is the lower limit and 3500 is the upper limit. Let us substitute the formula. N is 400, so 400 divided by 2, 200 is n by 2. Median class is 3000 by 3500. L is 3000, I just explained. So substituting all the values, when we solve, we can find out the median lifetime of the lamps. Let's take another example. If the median of the distribution given below is 28.5, find the values of x and y. In this question, the median is given 28.5. So if the median is given 28.5, it will fall in the class interval bracket 20 to 30. Now frequency is given over here. We need to take out the cumulative frequency. So this is how we take out the cumulative frequency. Remember, if frequency is missing and it is given by x and y terms, so this is the manner in which we write. So now we have got the cumulative frequency. We have got n, which is 60. So now let us put the formula and see. So it is observed that n is 60. So the first equation, x plus y plus 45 will be 60. 45 plus x plus y, you can see over here, is the last cumulative frequency column, which will always add up to n, which is the total frequency. Hence, 45 plus x plus y is equal to 60 is the first equation. Second, we substitute in the median formula. So median of the data is 28.5. It lies in 20 to 30 class interval. So median class is 20 to 30 and the lower limit is 20. Cumulative frequency of the class preceding the median class. Now if median class is 20 to 30, so the class preceding the median class is 5 plus x. So 5 plus x is the cumulative frequency of the class preceding the median class. And frequency of the median class is 20. And h is the difference between the upper limit and the lower limit of a class interval, which is 10. The same is being represented in the equation. So when we substitute all the values, we get x is equal to 8. Once we get x equals to 8, now in equation 1 we can substitute where x plus y was 15. So substituting x equals to 8, y is equal to 7. Hence, the values of x and y are 8 and 7. Another example to understand median. A life insurance agent found the following data for distribution of ages of 100 policy holders. Calculate the median age if policies are given only to persons having age 18 years onwards but less than 60 years. In this particular question, the age is given not in class interval form but as below 20, below 25, below 30, which means the number of policy holders is not frequency, it is cumulative frequency. Since below 20 is 2, so below 25 will include below 20 also, so 6 includes 2. Below 30 includes 6 and 2 also in 24. Hence, this is the cumulative frequency column, and now we will have to convert the first column to class interval column and cumulative frequency to frequency. So this is how it has been done. So class interval column we write down, since it is clear from the question the difference between the two intervals is 5, so the class interval is also having a difference of 5. Frequency we take out by subtracting the cumulative frequency from the previous row. First would be 2, second would be 6 minus 2, 4, third would be 24 minus 6, 8, next would be 45 minus 24, 21, 78 minus 45, 33, it goes on. So you get the frequency. Now 100 is n, so n by 2 is 50, and 50 would lie in the column 78. So 78, when we look straight, we get 35 to 35 to 40, which is the median class. Now we substitute the formula and we take out the median. Next example, the following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean and mode of the data and compare them. Here we need to find out all three: mean, median, mode. Let us take out first the median, for which we need to take out the cumulative frequency. Total is 68, which is n. So n by 2, when we do, we get 34. Now 34 will fall in the median class. 34, you see, will fall in the 42 bracket. So which will be in the median class 125 to 144. So this is the median class 125 to 144, and the cumulative frequency will be of the previous class plus frequency will be 20 of the same class. Substituting the values in the formula and simplifying, we get the median 137. To calculate the mode, we use the formula once again. Over here, to take out the model class, we will have to see which frequency is the maximum. So let us see which frequency is the maximum. We can see 20 is the maximum frequency. Hence, 125 to 144 is the model class as well. So we take out the mode using the formula and we get mode as 135.77. Now to calculate the mean, we either use the direct method or the the assumed mean method. Either you use the direct method by sigma fx by sigma f, or you can use the assumed mean method by taking out the deviation and then using the formula wherein mean would be equal to assumed mean plus sigma f1 d1 by sigma f1. You will get the mean. Now, to understand the relationship between all three, there is an empirical relationship which is 3 median is equal to mode plus 2 mean. So there are questions where you have to find out mean, median and mode. So you can find out two, and the third one you can use the formula to calculate. So you can calculate any of this using the formula. Thank you. May God bless you.